Hello everyone who is watching this video lecture. So in this video lecture series, we will be understanding the basics as well as analysis and design part of various type of concrete structures. Concrete structure mean we will be covering RCC structure basically as per the syllabus of the BTech Civil Engineering, and this subject will be having two parts. In this semester, it will be design of concrete structure part 1, and later on in the coming semesters, we will be switching over to design of concrete structure part 2. So first of all, let us try to understand that what are the contents or curriculum of this subject, that is DCS 1. So we have divided this subject into various units. In unit 1, we will be covering some information regarding the properties of concrete, and you have already studied the subject concrete technology. So in this unit number 1, we will be just brushing up your knowledge in some different way so that we can understand the basic properties of concrete which we can utilize or we can exploit in designing and analysis of concrete structures. Unit 2 will be covering the design and detailing of reinforced concrete beam. So Unit 2 will be devoted to design of RCC beams. There may be various type of beams. And Unit 3, we will be able to cover design and analysis of some slabs as well as staircase. Unit number 4 will be subjected covering compression members, that means axial columns, or there may be other type of columns. So whatever be in your syllabus, accordingly we will be covering the topics. And Unit 5 will be based on the footings, where we will be going through different types of footings, what is the role of footing and what are the various forces which will be coming on the footing, and how to do the analysis as well as design of basic footings. Now, since you have already studied in the previous semester the subject concrete technology, which were in very detail, that means you have covered detailed information about various properties of concrete, maybe fresh properties, that means fresh state concrete properties as well as hardened state concrete properties, and what are the various factors on which these properties will depend. And you have already gone through the concrete mixed design methodology also. So here we will be in unit 1 going through the properties of concrete in such a way that how we can utilize this information in the analysis and design of RCC structures. As we are very well aware, everybody knows that throughout the globe, concrete is the most useful material because of its basic properties and easily available material. So concrete can be prepared from locally available material which are easy to get, and we can exploit their properties as per our requirement. So let us go through some definitions which you have already studied in concrete technology subject, some basic definitions. So very first term is cement paste. Now you can understand That what is the meaning of cement paste? That means it is just suspension of cement particles in water. Cement particles are suspended in water, and that type of material is known as cement paste. Then we will discuss about the mortar, and mortar is, now you have added fine aggregates in the cement paste. So in simple language we can say mortar is suspension of fine aggregates in cement paste as per our design methodology. And next is concrete. Now what we will doing in concrete, we can say it is suspension of coarse aggregate in cement mortar which we have already prepared. So that means there are basically three type of materials. One is paste, other is mortar, and the third one is concrete. And accordingly, they have their different properties. Now, concrete can be further divided into, or you can classify concrete just as normal concrete. Normal concrete means it is just a simple cement concrete which we use in normal construction work. That means in simple construction work, not a specialized type of construction activities. Then second type is reinforced cement concrete. Now you can see here cement concrete is reinforced with some material. So we can just improve the properties of cement concrete by reinforcing some material. In the earlier years, you can say maybe 100 years back, cement concrete was actually lime concrete. So that time you can reinforce it with bamboos or straws or any other type of material which can reinforce them, so that we can just improve the properties of cement concrete where which properties that cement concrete is lacking. So later on you will be able to understand more effectively. So reinforced cement concrete is cement concrete plus reinforcement. That means here in our syllabus we will be reinforcing cement concrete with steel. So steel bars will be embedded in the cement concrete, and that composite material will be termed as reinforced cement concrete. More popularly it is known as RCC. Then another special type of concrete is fiber reinforced concrete. You can say it is FRC basically. So here what we are doing, we are using additionally some fibrous material. Fiber may be of many types. They may be of steel fiber or polypropylene fiber or any type of fibrous material. So what we are doing here, we are using fibers or we are adding fiber to the cement concrete. And other special concretes we can prepare so that we can modify the desired property of concrete as per our requirement by using some admixtures or some special type of material which can improve the properties which we want to improve of ordinary cement concrete. Now the properties of concrete which we are more interested in the design part. So first of all, very important property of every material, that is strength of the material. Whether it is a cement, whether it is concrete, whether it is steel or any type of material. So our main focus is first of all to explore what is the strength of that particular material. So here our focus will be on strength aspect or strength property of concrete. So in general, strength of material, any material, is basically a measure of the amount of stress required to fail it. Or in other sense, we can say what is the maximum stress which we can apply to that particular material so that it should not fail. So that maximum stress will be the strength of that particular material. Now in case of concrete structure may be subjected to direct compression, as in case of actually loaded columns, or there may be some tension or flexural stresses. In case of beams, beam will be subjected to flexural stresses. So various type of stresses will be there in case of concrete structures as per their utilization or as per their role. Now what is concrete? It's a very simple concept which we have to understand so that we can easily exploit their properties. So first of all, we have to define what basically concrete is. So we can say concrete is a composite material. So concrete is a composite material that consists of mixture of hydraulic cement, aggregate and water. These are the three basic materials. First of all, you need some hydraulic cement, that means cement which can give some chemical reaction when water is added to it so that it can give the binding properties. And the second thing is aggregate, and aggregate are of two types, fine aggregate as well as coarse aggregate, depending on the size of the aggregate. And third important part is water. Now these other things, you can prepare concrete only with the help of these three materials, or you can add some admixtures, some fiber or other cementitious material if you are interested in improving the basic properties of the concrete. And some cementitious material you may add some fly ash, some slag, silica fume, micro silica, and various other type of materials you can add on, and they will be termed as just as admixtures. You can even replace some part of the cement with some other material which will give similar or better binding properties. So here we are able to understand that what is concrete? Concrete is a composite material. So that means when concrete is getting hardened, then it will behave as a composite material, as a another different type of material. Now it will not be only cement or aggregate or water. Now very important assumptions which we take in the utilization of concrete. Now we assume that concrete is a homogeneous material. Now we are well aware that in general concrete at sites is prepared by hand mixing or some other mechanical way of mixing, and we are not sure whether you can prepare the homogeneous material. So to use its properties, to understand its properties and its utilization, first of all we have to assume that it is a homogeneous material so that we can assess its various properties. Now, as the term concrete, now let us understand concrete is basically a term which is originated from Latin word concretus. Now concretus means to grow. Similarly, concrete is expected to gain its strength till the process of formation of heat of hydration products happen. You are well aware that in concrete, cement react with water and it will produce some heat, and that process is known as hydration process. Now this cement will get hydrate and new products will be formed, just like CSH gel, and those those hydrated products will be having some binding properties, and those material which are now prepared having some binding property, what they will do, they will bind aggregate and other admixture etc. So that means it will be binding all the ingredients, and now you will get a hardened material. and that hardened material is known as concrete. Initially it was cement paste, then it became mortar, then now this mortar will be able to catch or bind all these aggregates to form a hard material, just like a rocky material. So sometimes concrete is also known as artificial rock. Now, in case of properties of concrete, very important property is compressive strength. As we know that concrete is such type of material which has very good compressive strength, very high compressive strength, and that compressive strength even you can change or you can modify as per your requirement. Now first of all, let us understand this compressive strength of concrete, because concrete is a composite material, so it will depend upon, or you can say it will get influenced from the constituents materials. So that means what are the ingredients. So compressive strength will directly depends on the ingredient, not only ingredient but also their relative proportion will influence the compressive strength of the concrete. In general, the size and quality of ingredient mean aggregate, cannot guarantee, so there is possibility of variation in strength of concrete even in same ways. That means if you are preparing a batch of concrete and you are using same aggregates, same bulk of aggregate, even then you can't guarantee that that batch of concrete will have the same compressive strength, because no aggregate is your aggregates are not of same size, or you can't ensure that each batch of concrete will be having exactly similar type of aggregates, because aggregates may be having size less than 20 mm, like that means size of the aggregate varies from 4.75 to 20 mm. So you can't be assured that in particular batch of concrete, or you can say if you are preparing suppose 10 cubic meter volume of concrete, you can't say that in each cubic volume of concrete aggregates will be of same quantity or same property. So what I want to say here, that if we have prepared 10 cubic meter of concrete, then there is the possibility of variation of compressive strength of each cubic meter of concrete. That means if you are taking some sample from a single batch of concrete and you are casting the cubes, then you may find that every cube will be showing some different type of compressive strength. So how to overcome this? Then we will be using now what we have mentioned here, keeping in notice the above issues. We have used a term that is known as characteristics compressive strength. So in actual, we are not calculating the compressive strength of a batch of concrete, but we will be terming it as characteristics compressive strength. It will be worked out for design purpose, and this characteristic compressive strength is based on the use of statistical data, and this statistical data and this characteristic compressive strength is as per the guideline given in IS 456. So here what we are understanding, that means if you are casting a number of cubes, suppose you have casted 100 number of cubes, then each cube may have variation in compressive strength. So to make utilize of concrete and to understand the exact compressive strength, we will be using the term characteristic compressive strength, not the compressive strength. Now what is characteristic strength? As per statistical tools, characteristic strength is defined as the strength of material below which not more than 5% of test results are expected to fall. So later on we will be able to understand it more effectively. Now you can see here one graph that is known as bell curve. Now here in the horizontal axis or along x-axis there is compressive strength, and along the vertical direction, that means along y-axis, we have taken the density of the number of tests. Now here we can take the example. Let us suppose we have casted 100 number of cues. So 100 number of cues you have casted, and then you will be making a table, and where you will be tabulating the strength, compressive strength you obtained from each cue. And then using the statistical analysis, as we have done in mathematics, you may be finding that most of the cues, or you can say, now see here in this graph, here 40 Newton per mm square is the strength. And what you are able to see here, that most of the cues are giving the strength of 40 MPa, that is 40 Newton per mm square. And some of the cues may be giving 35, some of the cues may be giving 30 MPa, some number of cues may be giving 45 MPa, some number of cues may be giving 50 MPa. So what we are observing here, that a bell type of curve is formed. Now as per statistical tool, what we will be doing, we will be trying to just shade here 5% of the area. Now you can see here the shaded portion is of having 5% of the area of the whole curve. So at this 5%, as per statistical analysis, not more than 5% of the test result are expected to fall. So from this figure, we can say that characteristic strength of this lot of concrete is 30 MPa. So it is very much clear from this graph that there are some number of cues which are having strength of 40 MPa, some of the cues having strength 35 MPa, and effective characteristic strength is 30 MPa. So characteristic compressive strength can be defined as strength of the concrete below which not more than 5% of test result are expected to fall. And here you have to take care that testing of Q sample should be as per the specifications or guidelines given in IS 516. Thank you. So here we are able to understand that what is the meaning of characteristic compressive strength and why we are using the value of characteristic compressive strength instead of actual compressive strength of the Q. Now, concrete is basically designated in terms of its characteristic compressive strength, which is a symbol we use is FCK, and we can designate it as ordinary concrete, standard concrete, as well as high strength concrete. Now all this information you can refer table number 2 of IS 456-2000. This table will give the guideline for different grade of concrete as per their classification. So this is table number 2. You can go through here. In table number 2 in IS 456, grade is mentioned. So here in first column, group, that means concrete is divided into some groups, then grade designation, then characteristic compressive strength of 150 mm cube size at 28 days, in Newton per mm square, more specifically as per the guideline mentioned in IS 516. Now, very first part is ordinary concrete. So what code has mentioned? Code has just listed M10, 15 and M20. That means up to M20 grade of concrete, it will come under the ordinary concrete and correspondingly their characteristic compressive strength is 10, 50 and 20 MPa. Now after that, from M25 to M55, all these grades are in mentioned as termed as standard concrete, and correspondingly they have their compressive strength, which is known as characteristic compressive strength in MPa, that is megapascal. Beyond M55 grade of concrete, these type of concrete are known as high strength concrete. Now here you can see the note that concrete is designated here M. You are well aware M is for mix and 10 is for the characteristics compressive strength in Newton per mm square, and this is the compressive strength obtained from 150 mm size cubes at 28 days of strength, 20 days of casting in as per Indian standard. Now second note mentioned in table 2 is the concrete of compressive strength greater than M55 design parameter given in standard may not be applicable, and the value may be obtained from special literature and experimental results. So you can say that this IS 456, it is better or they have the application up to M55 grade of concrete. Now another table, very important table in IS 456 is table number 5. Now what information is table number 5? That minimum cement content required, maximum water cement ratio, minimum grade of concrete. So we are more interested in minimum grade of concrete for different exposure conditions and with a normal weight aggregate of 20 mm nominal size. So you can see here in the first column some exposure conditions which are mentioned as per IS 456, that mild condition, moderate condition, severe, very severe and extreme. And correspondingly, as we are more interested in a reinforced concrete, because most of the design detailing will be for the reinforced cement concrete. So code has very clearly mentioned that what should be the minimum grade of concrete. So minimum grade of concrete in case of RCC structures, because we are more interested in RCC structure. So referring this table number 5 from IS 456, we are able to understand that minimum grade of concrete in RCC structure is M20 for the mild exposure condition. So as you go to the other type of exposure condition, that would moderate severe, you can see here the minimum grade of concrete as recommended by IS 456 will go on increasing. Now another important property of concrete is tensile strength. We know that concrete is very good in compressive strength and has poor tensile strength. So that is, concrete is very weak in tensile strength, approximately 7 to 10% of the compressive strength. Now here there is, I can say there may be one question which you can work out or you can find from the sources of information available from some standard books, that why tensile strength of concrete is so that it is just as 7 to 10%. That means why concrete is so poor in tensile strength in comparison to compressive strength. So you can just go through the literature from some sources, and when you find this answer, you can just put in the comments. Now, since there is concrete is very weak, as we have already told in the tensile strength. So direct tensile strength is not possible for calculation of tensile strength in case of concrete. So another ways we will be using, that is some other methods to just know the tensile strength. And as per code has advised us some information, some formula. That means for the design purpose, you can use that formula to calculate the flexural strength. And that formula is in clause number 6.2.2 of IS 456, where FCR is equal to 0.7 square root of FCK. FCR means flexural strength and FCK is characteristic compressive strength of concrete under consideration. That means if you have concrete of 40, yeah, that means M40 grade of concrete, then FCK will be 40 MPa, and you put the value here, you will be getting some value for the flexural strength, which you can utilize in design of the structure, design of RCC structure. Now another important property of concrete is modulus of elasticity of concrete. Again, for design purpose, code has given some information, and that is code has recommended this formula to just estimate the elastic modulus. That means modulus of elasticity. EC is modulus of elasticity of concrete, and that is given by this formula 5000 square root of FCK. For this you can refer clause number 6.2.3.1. So E is modulus of elasticity of concrete and FCK is characteristic compressive strength of concrete under consideration. If you have any type of doubt after going through this video lecture, you can just ask on in the comment section as well as in the regular class.